Good morning students. So now we are going to discuss about engineering physics unit 1 crystal physics. Okay. So we are going to discuss about crystal physics. First of all, we know understand the introduction of crystal physics, crystalline and non-crystalline solids, space lattice, then crystal structure, lattice parameters, crystal systems and Bravais lattice. These topics we are going to discuss about for this chapter. So first video we are going to make for introduction of crystal physics. So normally we know that matter we have classified the three types: gases, liquids and liquid crystals, then solids. So normally matter we can classify three types. So gases we know that some hydrogen, helium, these are gases. Liquids, water, kerosene, this is the liquid. And solids, normal materials we call it solids. So what are crystal physics? So physical properties of crystalline solids. Physical properties of crystalline solids. Determination of their actual structure by using X-rays or neutron beams and electron beams. Then classification of solids. So what are the solids? So we know that solid material we can classify three types: crystalline material, polycrystalline material, then amorphous materials. So we know the crystalline materials we have classified single crystal. Okay. So this is a polycrystal. For example, I have some pictures is there. Then crystalline solids. What is mean by crystalline solids? The arrangements of units of matter is regular and periodic. So atoms are arranged in a regular manner. We call it as a crystalline materials. Then anisotropic substance. Then sharp melting point. A regular shape. This is properties having crystalline solids. So non-crystalline solids. So amorphous solids, there is no regular shape, particles are randomly distributed. These are the isotropic substance, had wide range of melting point. These are called non-crystalline solids. For example, glass, plastics, rubber. These are the, for example, of non-crystalline solids. What is mean by polycrystalline solids? So polycrystalline solids we can classify many small single crystals, depends upon the many small single crystals. For example, high degree of order over many atomic or molecular dimensions, grain boundaries, these are the properties. And also grains, normally we have usually 100 nanometer to 100 microns in the diameter. These are crystalline solid material. Polycrystallines with grains above 10 nanometer diameter is called nanocrystalline. For example, inorganic solids, most of metals are and ceramics are the polycrystalline solids. Then crystallographic terms. Crystallographic terms we called as space lattice, lattice points, lattice lines, lattice planes, bases, and crystal structure, unit cell, lattice parameters. This is a topic we are going to discuss about few fundamental topics of crystalline solid materials. So what is meant by space lattice? Space lattice, regular and periodic arrangements of points in three dimensions. The atoms are regular periodic arrangements is called space lattice, identically surrounded to every other point in the array. For example, each point is surrounded by same. Then basis. A base is a unit assembly of atoms or molecules identical in composition, arrangement and orientation. Repetition of bases correct periods in all directions. The crystal structure is real while the lattice is imaginary. For example, aluminum, barium, and say NaCl, KCl. These are the, for examples of basics. Number of atoms, basis 1, 2, like that. Then crystal structure. This is a lattice. Each single atom is called as lattice. This is a basis. When lattice plus basis we combine, we call it as a crystal structure. Then what is meant by unit cell? So unit cell is a fundamental building block and repeating its own dimension in various directions gives a crystal structure. For this is for a simple hexagonal structure of unit cell. This is a normal unit cell. For this is a diagram. For suppose you cut the apple, we have small pieces. It's called as a unit cell.